Okay, sir.
coulombs inverse square law. You know the statement. Suppose we have taken 2 point charges q1 and q2 separated by distance small r. Then the magnitude of the force between the two charges is directly proportional to magnitude of product of the charges q1 q2, and it is inversely proportional to square of the distance. You know this formula, okay na?
Yes, sir.
Here this proportionality we can remove by placing some constant. That constant is k. So f is equal to q1 q2 divided by r square. Here if the two charges are positive charges, or if the two charges are negative charges, then the force will be repulsive force. That means for like charges there will be repulsive force, and if any one of the charge is negative, that means for opposite charges or for unlike charges, force is attractive force. Here when we are applying this formula f is equal to k q1 q2 divided by r square, we need not bother about sign of the charges. Direction of the force only changes based on the signs of the charges. And here this proportionality constant k depends on the units we are using and the medium between the two charges. If the charges are in air medium, then k value will be equal to 1 by 4 pi epsilon naught. Here epsilon naught is called permittivity of free space, and we know this value is 8.85 into 10 power minus 12 coulomb square per Newton meter square. If you substitute epsilon naught value in 1 by 4 pi epsilon naught, then we will get 1 by 4 pi epsilon naught is 9 into 10 power 9 Newton meter square per coulomb square. So for charges in air medium, force between the charges is given by 1 by 4 pi epsilon naught into q1 q2 divided by r square. This is the formula for force between the charges in air medium. This formula in vector form we can write like this: f bar is equal to 1 by 4 pi epsilon naught into q1 q2 divided by r square. Simply we multiply with r cap. This r cap is very important. This r cap is unit vector in the direction of f bar. In the direction of f bar. Next, if charges are in a medium, then force between the charges in the medium is given by this formula. Simply in place of epsilon naught, we will put epsilon. Therefore, you can write f is equal to 1 by 4 pi epsilon into q1 q2 divided by r square. This is the expression for force between the charges in medium, when placed in the medium. Here this epsilon is related to epsilon naught like this. Epsilon is equal to epsilon naught into epsilon r. Here this epsilon r is called relative permittivity. Relative permittivity of the medium, or we can call it as dielectric constant also. This is also called dielectric constant. So we can write epsilon r is equal to epsilon divided by epsilon naught. In terms of force we can write like this: F naught by Fm. Fm is force in the medium. Now this basic formula we can write it in position vector form. In position vector form we can write like this: sometimes what they give is they will give two charges with position vectors q1 and q2. Suppose q1 is position vector of charge q1 with position vector r1 bar, and q2 is another charge having position vector r2 bar, and this is the position vector of charge q2 with respect to charge q1. Then the force between the two charges is given by, from vector form, from triangle of vectors we can write like this. From triangle of vectors you can write a diagonal in opposite direction is equal to r2 bar is equal to r1 bar plus r bar. From this we can write r bar is equal to r2 bar minus r1 bar. Now we can write unit vector in the direction of r bar. By applying this basic formula, r cap is equal to r divided by modulus r. Here r is nothing but r2 bar minus r1 bar divided by modulus of r2 bar minus r1 bar. Therefore you can write force between the charges in air medium, we can write like this: F bar is equal to 1 by 4 pi epsilon naught into q1 q2 divided by r square into r bar is, r cap can be written as r bar divided by r. Therefore we can write F bar is equal to 1 by 4 pi epsilon naught into q1 q2 divided by r cube into r bar. Here we can substitute r bar value and r value, or simply we can write r bar divided by r, that is unit vector. This r cap we can directly substitute here to get the value of the force. So this is the basic information. From this basic information, let us solve some questions. How they are asking questions in examinations. See, first question: suppose two charges are given, q1 and q2, and are placed in air medium with separation r0, and same two charges q1 and q2 are placed in a medium having dielectric constant K with separation R. If the force between the charges in the medium is the same as the force between charges Q1 Q2 in air medium, that means in the two situations force between the charges is the same, then what is the value of R? We have to calculate R value. This is the question. Now here you observe the basic formula. Force between two charges in the medium is given by 1 by 4 pi epsilon. Epsilon can be written as epsilon naught into k into q1 q2 divided by r square. Here 1 by 4 pi epsilon naught is constant. Same charges we have taken in the two situations. So q1 q2, this value is also constant, and in the two situations force between the two charges is also same, that means F is also same, that is constant. So as F is constant, 1 by 4 pi epsilon naught is constant, and q1 q2 product is constant, then we are having only k into r square. That k into r square product must be a constant. That means kr square product in the first case and kr square product in the second case must be equal. Now we equate kr square product in the first case. In the first case, this is air medium, charges are in air medium. So for air medium, dielectric constant is 1 and distance between the charges is r naught. So this is r naught square, that is equal to kr square product in second medium. Second medium dielectric constant is k, distance is r, therefore r square. So we can write, if you take square root on both sides, we will get r naught is equal to root k into small r, or small r is equal to r naught divided by root k. This problem is very important, and importance of this problem is this one. Suppose charges are in the medium having dielectric constant k, then this r distance in the medium is equal to root k times r in the air medium. This is called equivalent path. Charges q1 and q2, if they are separated in a medium by r distance and medium dielectric constant is k, then this r distance in the medium is equal to root k times r in the air medium. This is the basic concept. Understood, M? Hello?
Yes, sir. Understood.
Okay, based on this, let us see one important problem. Suppose q1, q2 are the charges and they are separated by a distance r. Now in between the two charges, we are placing a dielectric of thickness T. Now we want to find force between the two charges. So how we proceed this? Just now we have seen a dielectric of length r is equal to root k times r in air medium. R length in dielectric is equal to root k times r in the air medium. This is the basic concept. Now we are applying this. Suppose that these two charges are in air medium, then the gap between the two charges will be like this. Except this dielectric remaining part, that means this part and this part, this total part length will be r minus t. This is the air gap length plus t thickness of dielectric. This t thickness of dielectric in air medium, it is equivalent to root k times t in air. So the air medium length between two charges q1 and q2 can be taken like this, that is r minus t plus root over k plus t. Now by applying basic formula, Coulomb's inverse formula, if we apply, we can get F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R minus T plus T root K whole square. T root K whole square. So this is the force between the two charges. Like this we are applying this basic formula. Now let us see few more questions. This is the basic formula for force. F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now if charges are in the medium, in the same medium, that means 1 by 4 pi epsilon naught is same and distance between the charges is also same, that means R is constant, then we can write F is proportional to Q1 Q2. This is the basic application, and based on this they have given some questions. A question is like this: 2 point charges Q and Q are separated by distance R in air medium. Then the force between the two charges is F. Now these two charges are kept in contact. Suppose that these two are two identical spheres and are given equal charge Q and Q. Now these two spheres are kept in contact. These two are identical spheres and kept in contact. Thereafter they are removed from one another and taken to the same distance r. Then what is the force between the two charges? This is the question. Same two spheres are removed and taken to same distance r. Then what is the force between the two charges? Now let us see. Here medium we are not changing. This is air medium and this is also air medium. Medium is same, and as medium is same and distance is also same, you can write F is proportional to Q1 Q2. F is proportional to Q1 Q2. So force in first case divided by force in second case is equal to product of the charges in the first case, that is Q into Q, divided by product of charges in the second case. In the second case, as two charges are kept in contact and removed, charge on each sphere becomes Q by 2. So Q1 is Q by 2 and Q2 is Q by 2. Therefore we can write F divided by F dash is equal to Q square divided by Q square by 4. So if you cancel Q square and Q square, you can get 4:1. Therefore F dash is equal to F by 4. This is the problem. Next we see one more important application: simple pendulums. Simple pendulums. This is one important application. Suppose two simple pendulums of same length and same mass are suspended from the same point, and both the spheres are given identical charge q. Because of the same charge, because of identical charge, there will be repulsive force. Because of this repulsive force, these two spheres will repel, and suppose that the gap between the two spheres is x, and here this semi vertical angle is theta, then this angle is also theta. Now in this case, what is the force between the two charges? Force between the two charges is equal to 1 by 4 pi epsilon naught into q1 q2, that is q square, divided by distance square, that is x square, and that force on this particular charge is like this. And this charge is connected with the thread, so tension will act like this. This is the tension, and weight of this pendulum will act like this. This is weight mg. Now if you resolve this tension into two components, you will get one component in this direction and another component in this direction. This angle is theta, means this angle is also theta. Therefore, if you resolve tension T into two components, you will get this side T cos theta and this side T sin theta. As this charge is in equilibrium, you can balance horizontal forces and vertical forces. If you balance horizontal and vertical forces, you can write F cos theta balances mg and F sin theta balances F. Sorry, T cos theta and T sin theta. T cos theta balances mg and T sin theta balances F. Now divide second equation with first equation, then we can write tan theta is equal to F divided by mg. Therefore, F is equal to mg tan theta. So this is one important formula. So whenever simple pendulums are suspended from the same point, we can use this basic formula F is equal to mg tan theta. Based on this, let us see one problem. Suppose two simple pendulums are suspended from the same point. Each thread length is L. Both are given same charge Q. Now the gap between the two charges is x. Now under the condition x is very small compared to L, what is the relation between Q and X? What is the relation between Q and X? This is the question. See here, suppose that this angle is theta, then this distance will be x by 2 and this distance will be x by 2. And in case of simple pendulums, this basic formula F is equal to mg tan theta. And here, as x is very small compared to L, under this condition theta is very small. As theta is very small, tan theta can be written as sin theta. Under this condition, Hello? Hello?
Yes, sir. I can hear. Hello?
Hello? Okay, ma'am. Here
Yes,
only
sir.
I
I
am
can hear
using.
you.
See here, F is equal to mg tan theta is the basic formula. As theta is very very small, tan theta can be written as sin theta. And here F can be written as 1 by 4 pi epsilon naught into product of the charges, that is q square, divided by distance between the charges, that is x square, that is equal to mg into, from the diagram, if you see, sin theta will be equal to opposite side x by 2 divided by hypotenuse, that is L. From this we can write 1 by 4 pi epsilon naught into q square divided by x square is equal to mg into x by 2L. Here 1 by 4 pi epsilon naught is constant and mg is also constant, 2L is also constant. By cross multiplying, you can write q square is proportional to x cube. This x square and x will multiply. So this is the relation between q and x. Did you understand, Emma? Hello?
Yes, sir.
Okay. There is one more problem connecting to this. Let us see that problem also. See one more problem. In this problem, they are giving information like this. Two simple pendulums they are given as it is. They have given identical charge q. Now charge leaks at constant rate. This is the condition they are given. Charge leaks at constant rate. Then what is the relationship between velocity of these pendulums with the distance between the two charges? They are asking relationship between v and x. They are asking relationship between v and x. This is the problem they are given in previous exams. And now let us try to solve this problem. Just now we have seen q square is proportional to x cube. This is the relation between q and x under the condition x is very very small compared to length of the thread. Now you can write, if you take square root on both sides, you can write q is proportional to x power 3 by 2. Now I differentiate on both sides with respect to time. So when you differentiate q, we can write dq by dt, and it is proportional to x power 3 by 2 differentiation. You know basic formula, differentiation of x power n is n into x power n minus 1. We are applying same formula. Here n is 3 by 2, so 3 by 2 into x power n minus 1, n minus 1, that is 3 by 2 minus 1, that is 1 by 2, and we have to differentiate this x also with respect to time. Now see, in the question they are given dq by dt is constant. See, this is constant and 3 by 2 is also constant. So we can write x power 1 by 2, x power 1 by 2 into dx by dt. Dx by dt is nothing but velocity, that is equal to constant. Therefore we can write v is equal to some constant divided by x power 1 by 2. This x power 1 by 2, if you bring to the right side, it becomes x power minus 1 by 2. So we can write v is proportional to x power minus 1 by 2. This is the answer. Have you understood, Emma?
Yes, sir.
Okay, we see one more problem connecting to this. These are all very, very important. Many times in previous exams they are given these models. So, see one more problem. See, these are the two pendulums suspended from the same point. Length of each thread is L. Now they are separated by X. If this arrangement is taken to gravity free space, what is the force between the two charges and what is the angle between the threads? This is the question. So here what happens? If they are taken to gravity free space, mg will not come into act. When mg will not come into act, each pendulum due to repulsive force will go like this. They move apart and they will come to straight line like this. They will come to one straight line like this. Now the gap between these two charges is how much? This is equal to 2L. And what is the angle between these two threads? This is equal to 180. That means theta is 180 and gap between the two charges, that is x, that is equal to 2L. Once we know gap between the two charges, we can find force between the two charges. By applying this formula, F is equal to 1 by 4 pi epsilon naught into product of the charges, that is q square, divided by distance between the two charges is 2L. 2L whole square is 4L square. So this is the answer. Okay, Nema? Have you understood?
Yes, sir.
Okay, today we will finish this one.
Okay, sir.
Thank you.